So for today, I'm hoping we're going to cover 2 chapters. I don't know if we'll be able to finish both. They're short, chapter 5 and 6. Chapter 5, how to structure object-oriented applications, and in chapter 6, how to debug. These chapters are short and the exercises are pretty short, and I'd like to do them together instead of let you have open lab with them, especially for the debugging, because I'm just going to show you how to use the debugger using the exercise at the end of the book. So that's what we're going to do. And also I wanted to say that I noticed that when I give you open lab, often many of you leave earlier than the class is over, and I want to make the best use of your time. So I know sometimes you might have to leave, and that's okay, but generally speaking, I would like to see you work, or you can show it to Kira before you leave. If I gave you an exercise to do before you leave, I would like to see it to Kira, as I just said. I don't know why I said this twice. It's been already a long day, I guess. So let's get started with chapter 5. Shifting between JavaScript and Java. Some makes it stall. All right, so this chapter is about structuring Java applications that are object-oriented. And we have learned about packages, and a common way to structure applications is with a 3-tier architecture, such as presentation, business layer, and database layer or tier, because it just makes sense. Usually a realistic application is going to have these different tiers, and so we can set it in the following way. The presentation classes, the classes that you're interacting with the user, are going to go in the presentation tier. Your business classes are going to go in the business tier. So what are the business classes? Any type of business rules or business classes. So for example, how you calculate the customer discount, who is a preferred customer, who gets shipping rates of various discounts, or just anything that has to do with the business rules will be represented in business classes. And then the database tier is going to contain the database, which is not really something we're studying here, for example, MySQL database. And then the way we work with databases is by creating classes in the language such as Java that actually model the database entities. So if we have a database with certain tables, we're going to create classes in Java to map to those database tables, and then the database can talk with Java. Okay. What are the advantages of having your architecture divided up in the following way? There are several of them. One of them is encapsulation. So if you have your different classes in these different folders, you can have Kira working on presentation layer, Daniel working on business classes, and Danielle working on databases independently of each other. And all you need to know is the signatures, how to call the methods, and everything else. You can work on your own, and also you can make a change. So Danielle can make a change, but as long as the interface is the same, you don't care. This is what is so great about encapsulation. You just get to use it. Even maybe in the first version of the program, you actually don't have even a database. Maybe you just have a flat file, and then eventually you change up so you have a MySQL database. But your interface doesn't have to change. And this would be an example of encapsulation. And so these are the advantages, and let's see what else. On the other hand, if you needed to share the code, it's also available to you, and you can share it. So you both can share the code, but also divide the labor and use encapsulation. That's the big picture of the 3-tier architecture. So in our example so far, we haven't used GUI, which stands for Graphical User Interface. So what would we have? Do we have a presentation layer here if we don't have a GUI? We do. So what might be our presentation layer? What do you think would be the presentation layer in the classes we've been doing so far? So the presentation, Danielle?
The console.
The console will be our presentation. As long as we're interacting with the user, it doesn't have to be GUI, right? So anything that interacts with the user is going to go in the presentation layer. And in our case, this will be the file containing the main method, most likely.
So it's arguable whether or not it's graphical.
It's certainly not graphical. Well,
So
yeah, I guess it's arguable.
Yeah.
If we have time towards the end of the book, we're going to use some GUI forms in Java. You probably have used forms in C#, and we did use it in Python as well. And then the business tier. So as I mentioned, so we have a product. We had our product class that created assigned different names, and then created discounts. I think we had this example. So or if we didn't, consider an example where you give different discounts based on the different amount of the purchase. If you buy something over $100, you get 10% discount, over 220%, and so on. So that's a business rule, and the business rule would go in the business tier. And then finally, the database. We have something like a database, the product DB class, and that's where we assign values to our fields based on some casings. So this is almost like if you extend it to a next level, you'd have MySQL table where you query, and then you can do, you don't create necessarily, well, you can create records. So CRUD, create, read, update, and delete. All right. So it turns out that it's very handy to use packages for organizing your files. And packages are nothing more than folders and files. So we can have a folder source, and then Murak, and then business, DB, and UI. So these are your packages. Business, DB, and UI are pretty generic names, so you might have problems if you just name your packages like that and then hand it over to someone else or work with someone else. So to get around this potential problem, what we do is usually we use the reverse domain notation to preface our packages. So for example, my domain name is stanimeredith.com. If I was creating my own package, it would be com.stanimeredith. and then business, and this would make it unique enough so that there is no name collision. All right. We don't really have to worry about it here, but generally this is the practice. You use a reverse domain to preface your packages so that they're unique. So here is some, if you have a package, you have to import the package, and we have to specify, the name of the package at the top of your class. And if you want to work with other packages, as you know, you have to import them. And it turns out that if we didn't have Eclipse, when you create packages, you'd actually have to create folders on your hard drive to match the package names, and that's quite cumbersome. With Eclipse, it just takes care of it for you. It even updates it automatically, so it's very helpful. We're going to do some examples here. So I'm going to skip over the code and we'll just do it hands-on. So here are some class diagrams written in, what notation is this? Danielle? Diane? It definitely has camel case, but all those diagrams are written in what language? Do you remember? UML was what I was looking for. Definitely has camel case, as it should. These are examples of camel case. So unified modeling language. And these are diagrams to show how the different classes in class diagrams relate. Again, skipping over the code because we'll do it hands-on. So that's the material for chapter 5. And now let's dig in and make some changes to packages and see how they work. And we will review the line item app and run it as well as part of this exercise. I'm tempted to take a break now, though, before we start, so that otherwise we start and then 10 minutes later take a break. So take a 10-minute, and then we'll start on our chapter 5 coding exercise.
No, it wasn't done by a lot of it.
I did it and put it on my hard drive. Last week, and when I went to look at the page, it said it was corrupt. So I had to just shut it down right over again. I ended up just installing ITC on my laptop.
I have a Linux for that. That's also just like, why would you require a concert? I don't think I'll ever probably use it. Sounds of things I can't use. I can't go home and use it on my computer.
Get everything.
I'm just hanging out here on the weekend.
Yeah, that's why I'm
Next time I'll tell you a story too.
Okay.
We started at 150, correct? At the break. Couple more minutes and we'll start again. Did you take a look at the comma, the next comma here? I want to make sure that everybody knows to use the class. Did I? Make sure to use the class.
Oh, let me see.
Yeah, let me see. You use your code words, I'm not worried about that. But I was worried that you're not using the archive format that we need so we can import it. So how do you use that?
I'll send it again. This is like the good side. I'll send it again.
This is the thing I want to do. I don't know which one.
Oh, I didn't get it.
So let's see.
Yeah.
Sometimes you go to the line because it's going to make the project the same and there's some collisions. So we use the line.
Okay, I checked it. This is done.
People for me is hard.
Okay.
So did everyone hear me to use a class for the grade? Otherwise, it's simple. Let's move on to so you get to follow the directions as far as well. Yes, this would be the one that contains a name. All right. So let's work on the exercise on page 144, exercise 5-1, and we'll do it together. Excuse me. So start Eclipse. Make sure I'm screen share here. So this exercise, modify the line item application, guides you through the process of testing and modifying the line item application that's presented in the chapter. Step 1, import the project name chapter 5 EX1 line item that is in the starts folder. So you should have this available on your flash drive. So we're going to import existing project into workspace. That's probably not an archive file for you. Let me magnify to take a look at the packages. Chapter 5 underscore EX1 underscore line item. In fact, I'm going to delete everything else from the workspace. Does everyone have the file? If you don't, I can give it to you on the flash drive, but hopefully you do have it. Just let me know. Okay, and so the file has the packages as we discussed for best practice, the preface of the domain, Murak, and then business, database, and UI. So Kira, we just imported chapter 5 EX1 line item, and we're going to work on page 144 with the exercise 5-1. Yeah, we're importing the starter code.
So in general, it's import existing projects.
Yes, and it's not archived. Probably. Do you have it?
Yeah, I have
It should be on a flash drive
yeah.
or somewhere. Okay, and then run the project and test it with valid product codes. So let's go ahead and run this. So I have to get to the. So again, the Murak UI contains the line item app, which is our UI. It has a main, so it's going to show on the console here. Product code, the valid product code suggested are Java. So it's working to set the price in quantity and the total. And then we're told to also check it with JSP. That seems to also work correctly. And then with MySQL handbooks, and that also seems to work correctly. So these are 1 and 2 subpoints 5-1. But we need to also take a look at the code because we haven't really looked at it yet, right? So we actually don't know exactly what this application does. So let's start with the business package. It has 2 classes. The product, and we should be all familiar with the product from previous exercises, previous chapters. It has 3 instance variables, and what it does is sets and gets the values for those variables, and also it will give us a formatted price, right? Do you have any question on the product class? Okay, is everyone working with me on your machines though, or following? All right. Okay, so there's the product class. It's going to define the product. The line item class is going to define the line item, and it's going to have a instance variable of type product. So it uses the product class for an instance variable as well as the quantity. And then we have a constructor here for the line item, a custom constructor to set the product and the quantity. And again, is everyone comfortable with using objects as arguments at this point? So you have to pass the class name and then the identifier, in this case, product. Otherwise, it works the same as the primitive types. And we can get and set the product, get and set the quantity. And there is also a method getTotal, which we used to get the total for the different types of line items. And the total is going to return the quantity, which is the instance variable, times the product dot get price. So this is getting this from the product class. And then in the same package, so it just sees the product there. Okay. Sorry, it's not Okay, this is happening not because they're in the same package, which that's good to know as well, but because we have it as an instance variable in this class, and therefore we have access to the methods and properties, right? So again, calculate the total, which is the quantity times the product.getPrice. Those two are instance variables in the line item. And finally, we have get total formatted. Here we're calling a method within the class, so we're using the this keyword to signify this is an object, the current object dot get total, and then we calculate the get currency instance, format, not calculate, but rather get a currency instance, format the total, and then print it to the user. And these are the methods that were called to display our line item information as I was testing the application, right? Any questions so far? Okay, the product DB should be familiar as well. So the product DB has a method, a static method get product. We create an instance of the product object here, and then we set the description and price based on the product code. And then we return the product. And this allows us to know what is the correct description and price when I enter Java. How does it know that it's Murex Java and the price is 57? It's because right here, if the code is Java, we set the description to Java programming and the price to 57.50. Okay? So this is the DB class, and finally the line item app. We start with the main. Creates a scanner, and then it asks you to enter the product code. So for example, Java and the quantity. And then you call the get product method of the product DB. And the get product returns a product, therefore we are storing the return value in a product type. And we're passing a product code to get product. The other point to note here is that get product was defined as static in the DB, which is why we're not creating an instance of the product DB class. We can just call it on the class. And we're saying return product. So that's why when we call this method, we store the result in a product type. And get product takes a string product code. And that's exactly what we're doing here. We're passing the product code that the user entered, and that's how everything becomes connected. The user enters the product code, and then we pass it as an argument to the get product method of the product DB class, and then we return a product. And then we create a line item that takes a product and a quantity, and then from there it's just a matter of calling the methods of the product and line item to display to the user. If you have time, maybe if we have time, it might be helpful to draw how these connect. Do you feel like you have a good sense how the different parts connect from the different classes, right? So we are essentially jumping between classes so we can make this work, but we start with the main as the entry point. So no question? All right. So this was the review of the line item. And now the next part of 5.1 is to rename a package. So in the Package Explorer, navigate to the MorackDB package and rename it to morack.database. So this is the package, and with Eclipse, we're going to go to refactor, rename. Again, to rename a package, right-click, refactor. It shouldn't matter where we are, because now it doesn't matter. What matters is that we are working here on the Sofian. Okay. You can be in any class, it doesn't matter, but you just have to click on the right click on the package that you're trying to rename. So I right click on the MorackDB, refactor, rename, and we want to rename it to morack.database and save. Open the product.db class and note that Eclipse also renamed the package statement for this class to correspond to the new package name. And sure enough, on line 1 here, we didn't have to do this ourselves. Eclipse renamed it for us, so that's helpful. And also, if we were doing this outside of Eclipse, we would have to go and change folder names. So Eclipse is actually helping us out a lot to do this. And this was exercise 3, 5-1, item 3, and 4, and 5. Open the line item app class and note that Eclipse also changed the import statement for the product.db class to correspond with the new package name. And indeed, it made a change here as well to now say database instead of DB. And run the project and make sure it still works correctly. Okay. So let's test it out. Enter product code, JSP 5. And it is giving me the correct information. And I'll try this one more time with the product code of JavaScript, which is not part of the available products. So it's giving me 0s and 5s, and a total of 0 as well. Okay, any questions? Great. I don't think we need to do 5-2. Maybe I'll let you do it if we have time for Open Lab. I think what I'd like to do now is move on to chapter 6, unless you have any questions. This one's, I don't think, much more to say. You know how to rename packages now. You know what is the proper structure for naming your packages in the 3-tier architecture. So that's pretty much what you should know about it. All right, so let's see here. Get out of the Eclipse for now. Close this, chapter 6. Where's my pointer? How to test and debug an application. So we're moving on to chapter 6. And it will teach you, I will teach you how to test and debug an application and what is the difference between the two. And then we're going to learn how to use the debugger, which is a very powerful tool to help you debug errors in your code. Is there an error here? And if so, can you point it to me? Here.
Instead of multiplying it by 2, you're adding 2.
Okay, so this is an example of a logic error. And we need to fix, obviously, the plus, make it a multiplication. So this is a logic error. Everything seems to be working fine, except we're not getting the correct result. Okay, so the difference between testing and debugging. Testing is the activity where you actually try to break your application, so you try to make it fail. And once you make it fail, then you engage in debugging, which is where you debug your code and try to fix the error. And testing is a big topic, and there are many different types of testing and testing frameworks, so I won't really go much into that. But maybe at least I can say that the same way as we have the 3 tiers, UI, business objects, and database, you need to account for testing these different areas. You also need to account for what we call border cases. So maybe everything works fine when the user enters valid input, but what if they enter something out of the norm? Will your app crash, or will it handle it in a more graceful, what we call graceful way? And also, what if you can do maybe load balance testing? So what if you have a situation where too many people hit your server or your application at the same time? How many people do you expect would hit your application at the same time and are able to handle this properly? So again, there is a lot more to testing, but the goal is to break your application or to make it fail, because it's better to make it fail now instead of in production. It's always more expensive to fix any kind of bugs if they are in production, right? This is getting more easily resolved now because you don't have to wait for the next release of the package that you have to plug in with the CD-ROM, but you can just do updates, continuous updates. So that's getting a little better, but in general, still, we don't want the errors to get to users. Okay, and so again, then debugging is, as a developer, you will go through the code, debug, and then fix the errors. And also, it's common, you have test engineers who do the testing, whereas debugging often will be handled by the developer, him or herself, themselves. Okay, so check the user interface to make sure it works correctly. Check for valid input, and also with invalid input. And normally in a work type of situation, you'll be given a specification you have to test against. In our cases, that's why I hope that when you do your homework, try to follow if I give you screenshots, try to follow them the best you can, because this is your specification. So there are 3 types of errors that can occur: compile, runtime, and logic errors. Did we talk about those? I believe we already did. So you tell me then, Han, do you remember how would you describe a compile time error? What is an example maybe of a compile time error? Syntax. So if you have a variable name with a lowercase and then call it to the uppercase, it will be a syntax error with red markings from Eclipse. So those are the easiest to fix, because you just go and fix it. A runtime error can cause, for example, if you're expecting a number but the user enters a string, it's going to result in a runtime error exception. And you don't want your users to see runtime errors. So you try to handle those. And then we just looked at the example of a logic error. Here's some code that contains some typical errors. So these are syntax errors, getting a semicolon. You only closed 1 parent here, you should close 2, right? So closing parentheses. Product code is equal to next line. Well, in Java, we can't do that. No data type declared. We need to say that product code is a string. So we have to declare the data type and essentially declare the variable before we can use it with the correct. And then improper capitalization, which word here is the problem? This needs to be lowercase, okay? So these are some examples. of errors. And as you have errors of your own, some things to check and consider. Do you have a semicolon at the end of your statement? Again, parentheses. Did you declare the type of the variable? Do you have an incorrect case? And are you misspelling an identifier? Right? And what is an identifier? Muhammad, what is an identifier? You know this. Diane.
I knew it like 10 minutes ago.
You guys all know it. It's
Give me
just
like 3 seconds.
all right. Sure. 1,000.
Let's see. Unique address for the instance of the class.
Okay, so this was the identity.
Oh, what was the one I was in?
Sorry, identifier.
Oh, I'm not sure then.
Okay, but this is good to remember. So we had a quick review on the identity. So identifier is any type of variable or method that you name. If you give it a name, it's an identifier. So it's a programmer named entity in your code, such as variables. Okay. Well, the identifier specifically refers to the ones that you give the name to, as opposed to keywords. But you can certainly misspell a keyword as well.
So like you're going like a method called like get price, and
Yeah.
you capitalize into initially you named it with a small lowercase v at the beginning, then later on you call it try calling it with a capital.
Exactly. This would be an example of your misspelled identifier. All right, so this is what a compile time error looks. It will point you to the line number, which is great. And then the runtime error, you're going to see something like this happen. So this is very helpful information. In fact, this is what we call a stack trace. This is in reverse listing the methods that were called that led to that error, with the last one being including the line of code where the error took place. So now if you see this, do we have a,
It's an Amber Alert.
what is it?
It's an Amber Alert.
Oh, okay. I thought it might be something, it's calling me, so sorry about that. I don't know who it is. All right. So now you can go to line 25 and start looking, but it's very helpful to have the stack trace so you can figure out where it is to start looking for the problem. Right? In this case, what is the problem? Can you see this? Gunther?
X isn't a correct variable for you need to put a number in.
That's right. So we're trying to give it an X, which is a string, and this is simply not going to work. It had to be 25 or 10, an integer. So this is if you get the runtime error, you'll be able to compile, but then you're going to have, your code will run, but then you get an error such as this one. And more specifically, this type of error, it's an exception. More on exceptions later. And we already discussed an example of logic error. So how do you go about debugging your own code when you're working on a program? One of the simplest and easiest and really nice ways to go about it is to just add your own traces, which are print lines. As you go through the code, you add your own print lines, and this allows you to see, oh, here is now I'm in the get total method, and this is the value, and now I'm exiting the method. So this is very helpful. You just have to remember to take out those lines before you submit your assignment or before you release your code. But again, just adding and you start by adding just a few to get an idea. Is this useful enough? Maybe you need to add a few more. And next, finally, we're getting to the debugger. And I'm going to show you in a moment here, but just a couple slides. So Eclipse and one of the differences between a code editor and an IDE is that an IDE comes with a debugger, which is a very powerful tool. And the debugger allows you to do some debugging, including setting a breakpoint. And if you set a breakpoint, which is this little blue dot here, that's where the execution is going to stop. And the debugger is going to allow you to take a look at the values of your variables instead of after everything ran on the line where the breakpoint was set. So that's one thing we're going to do. And then you can look at values of the variables. And these are the debug buttons and shortcuts for Eclipse. So what can you do with the toolbar button? You can step over. So as you're going through the methods, if you're sure maybe that the problem is not in the get number formatted, you can step over this method. So that would be F6. Or maybe you think the problem is in your calculate discount method. Step into with F5 and line by line, it will execute and you have to look at the values. Step return, I forgot what it does. It's not really used very much. I have to look this up. Let's see. Does anyone remember off the top of your head? Step return?
You just stepping out.
It's just, I think it just steps out of the method. Right. So step return
Where it continues forward
to the calling point. Right. So it's going to continue to the calling point where you left off to go into the method. Okay.
well, I mean, just to the outside the method, because it doesn't matter if you went into there,
Right.
you stepped in.
Okay. So the step return will take you out of the method. All right. Resume. If you're continuing debugging, and then you can terminate with Control F12. So let's go ahead and do some of these exercises together at the end of chapter 6 and practice using the debugger. So this would be page 163, exercise 6-1. This exercise guides you through the process of using Eclipse to test and debug an application. This should give you some idea of how useful the Eclipse debugger can be. Just 1 second here. Okay, so my apologies. The step return finishes executing the code in the current method and returns to the method. Right. Okay, so back to exercise 6-1. The first step is to import the files we're going to work with. So go to Eclipse and then import. Chapter 06_EX1 line item. And let me delete this. Open the line item app file that is in the Murak UI package. Okay, is everyone ready? Did you all import the file? All right, so then we're going to start going through the steps of the exercise. Delete the semicolon, so, 6-2. Delete the semicolon at the end of the statement that prints the welcome message and save the file. This should display an error in the code editor. Replace the semicolon at the end of the statement. This should fix the error. And we just demonstrated compile time errors. And next, we're going to introduce and examine a runtime error. Run the line item application and test it with a valid product code. So Java. And then try it again with an invalid product code. with a valid product code and an invalid quantity of 10 as a string. So Java, and then for the quantity, enter 10 as the word 10. And this gives us a runtime error. This should cause the application to crash and print an error message to the console window. Did you all crash your application? Study the error message and note the line number of the statement in the line item app class that caused the crash. Then click on the link to jump to a line of code. This should open the line item app Java file and highlight the line of code that caused the crash. Based on the information, you should be able to figure out that the application crashes because 10 isn't a valid integer value. In Chapter 8, you'll learn how to handle this problem. All right? So again, the bottom line is where the error occurred. So I'm clicking here on line item Java 25. And it takes you to this line of code. And again, we see here that we need an int, and we passed a string. And this was our runtime error. What we need to do is some error handling, which we'll do later to learn how to prevent the user. What we should do is have a statement to check if the input was not an int, and we can tell the user this is not valid, please enter again. And we're going to come back and do this later. Next, set a breakpoint and step through a method. Open the line item class. And set a breakpoint on the first line of code in the getTotal formatted method. Okay, so how do we set a breakpoint? You can use the tools up here, but also you can just double click on the line number. And as you can see, I don't know if you can see it, but it created this little blue circle, which indicates a breakpoint. So double click on the line number, and this created the breakpoint right here. Do you see it on line 42? The little circle? So this is the breakpoint. Click on the debug button in the toolbar. This runs the project with the debugger on. Here. So the debug, there is a little bug next to the green button. Oh, you guys can see the top. Hang on. I guess it's cutting off the top of my screen. So let me do this. So you know how to run the line item app. Next to it, there is a little bug that says debug line item app. So you want to click on there, on the little bug. Okay. Probably cancel this or allow. I think we have to cancel out of the firewall. Again, if you didn't see it, I'm magnifying the screen here. And again, this is the debug button. And if you hover over, it will say debug line item already running. Is everyone able to find the little bug? Okay. Let's see here. Click on the console tab to display the output window and enter the value. So this is the console tab. Enter the value of Java for the product code and the value of 3 for quantity. So Java, and then 3. When you do, the application runs to the background breakpoint and stops. If Eclipse prompts you to switch to the debug perspective, click yes. So now here we're going to click yes, and I will just remember my decision. And when we did that, Eclipse changed from the default perspective, the one where we work, the Java perspective, to the debug perspective. And this screen here is the debug perspective. So it's just a different view that you get with Eclipse. I want to make sure you all can bring up the debugger, the debug perspective. Any question on that? Okay. Up here in the top right corner is where you can switch between the Java perspective and the debug perspective. And right now we're good in the debug, that's where we want to be, but you can switch between the two. So I'm going to now resume following the steps of the exercise. In the variables window, expand the variable named this. This allows you to view the instance variables for the current line item. Okay, so let me go back to, here is the variable window. It says variables, and it has one variable this. So you have to click on the little arrow, and then it's going to show you the properties. So this is the beginning. Now we're on the same page. Okay. So this is the variables window, and then we expanded the variable named this. This allows you to view the instance variables for the current line item object. Note the value of the quantity instance variable and expand the instance variable named product. This allows you to view the instance variables for the product object that is stored within the line item object. So the value of quantity is 3, and that's what we entered, right? And this is the product, and the product has a code, which is Java, a description, which is Murex Java programming, and the price of 57. So you get to see the values of your variables at the breakpoint, and this can be very helpful, right? Next, click the Step Over button in the toolbar repeatedly to step through the statements in this method. After each step, review the values in the variables windows to see if they have changed. So the function for step over is F6. So I'm going to click F6. And you can see now that we are on line 44. We have also a value for the currency variable. So it's updating the variable values as we are stepping through. And now we also have total formatted, and it's showing us the value of this variable. Click on the resume button in the toolbar to continue the execution of the application. So were you able to use F6 to step over and see the changing values in the variables? Okay, I'm going to leave the screen up. So I have now ran through the entire method with F6, step over. And let's make sure that everyone can see all these variables and their values. So now we should be able to solve those. Now say F6. And F6 again. So we need to also this back. Okay, let's do it again. We have values over, so let's do it. Now we should be able to do 6. Say next time say it never works. So we're ready to do those? Are you put the same program? So it's now running to you. You know to the method, but it's now running to the back program. It's showing the different values. That's what we're trying to do.
Yeah, and I understand. You can transfer one thing.
Exactly.
One or the other, and then make it something.
And look at the values here. I don't know why it's skipping over that method though. All right, did everyone accomplish looking at the variables? Okay. Next, click on the console window again. Then enter N to exit the application and end the debugging session. See here. Wait, I think I need to go back. Click the resume button in the toolbar to continue the execution of the application. So did you find the resume button up here? It's sorry, I have to switch between magnify and not magnify, and that's just confusing. So this little button, it was green before I clicked it. That's the resume button. And if you click it, then you will be at the console. You're going to see a question, continue yes or no, and then you say N for no to exit the application and end the debugging session. Next, so now I'm on step 13 on page 164. Click on the Java button in the toolbar to switch back to the Java perspective. And again, this is the top right corner of the screen, which is cut off on the monitor, but right here. So that's Java, and now you're back in the Java perspective. Open the line item class and set the breakpoint in the first line of the main method. Do you want me to let you work through? I think I'm going to let you work through the rest of these by yourself because you now have the idea what you need to do. So just follow the steps 14 through 19. And then once you're done with this, you'll be done. And I can take a look at your I don't think I can actually look at this, but when you're done, you're done. Do you feel like you had a good exposure to the debugger at this point? Or? It's very helpful, and we'll use it again. So that's all for today, and now we have Open Lab until the rest of the class.